Good afternoon, ladies and gentlemen, depending on where you are joining from. So my name is Belén Gallego, and I am here today from Mata Insights, and I have the opportunity of having here with me three top experts in terms of PV development, and we're here to discuss how to make PV projects more competitive. Because as we have seen over the past few months and years, the prices of the PPAs have kept going down, and this is really consistent across the board. So it comes to a point where we have to get cleverer and cleverer and use those quantum leaps to make sure that we extract every single ounce of opportunity out of these projects, because the prices are no longer being decided by dollar amounts, but by penny amounts. So with me here today, we've got Vikas Bansal, the head of business development from Sterling & Wilson, who's going to give us the EPC perspective. We've got Eduardo Gonzalez from Jinko Solar, who's going to give us the developer perspective. And then we've got with us also Álvaro Payán, who's going to give us the technical side as a technical advisor, both sides of things, and a few comments. So before we actually begin with the presentations, I'd like just to stop sharing this and ask you guys a question so that we know what we're dealing with here. So the question that I would like to ask you, and I'm sending it now to your screen, and I would appreciate if you guys please could vote. It's very, very simple. Is when will you think, or when do you think we will see a $1 kilowatt hour bid? Will this be quickly? You know, will this be next year itself? Will we see this $1 mark this year? Will it be the year after? You know, we're pretty close, but we're still a little bit while away. Will it be in 3 to 5 years? Is it still going to take some time, but we will eventually get there? Or do you think it will never happen? You know, the prices will bounce back up, and we will actually see a reversal. Please, you know, we all have the opportunity to vote. Please, I will ask as many of you as possible to vote. I know some people don't like to, but it would just be a way for us to understand, you know, how many people are currently in the room. So I'll just read it one more time and give you a few extra seconds. You know, Christian just points out, you know, it depends on the market. Yes, correct. It does depend on the market. I just, you know, for the first time, you know, when will we see a $1 kilowatt hour for the first time? Will it be next year? Will it be the year after? Will it be 3 to 5 years? You know, are there many risk-averse people in the room who think, you know, better push it back to the future, or it will never happen? You know, which is also a possibility. So, okay, not everyone has voted, but I'm going to show the vote as it is. I'm just going to count back 3, 2, 1. You get the end votes, and this is what we ended up with. Not a lot of people think it'll be next year. Few more people think it'll be next year. Most people think it'll be in 3 to 5 years, and actually the second, I guess, yeah, is more or less it will never happen. Here it is. This is the results of the poll. Sorry, I thought I had showed it to you. So this is how it goes. Actually, most people think it will happen in 3 to 5 years. So this is very interesting, you guys. Eduardo, Vikas, Álvaro, you now have a little bit the understanding of what's going on through people's heads. So, Eduardo, you're the first one up. Please go for it. Unmute your microphone so we can hear you.
Yeah. Hi, everybody. Good morning. Well, good afternoon for the ones that are Middle East. Well, regarding the question that there is a comment on, around there, it is US dollar cents. Of course, it's not US dollars. Anyway.
I am so sorry. US dollar cents. Put my hands up. It's a typo. I'm sorry.
Okay. Well, I'm going to explain from the technical point of view what's our internal, let's say, optimization process to let's say, to obtain the best scenario in terms of for tender process and so on. So the let's say the first consideration when you are starting this tender process is to analyze, of course, the boundary conditions of the project. So that means to from every point of view of regarding the available area, how is the shape, the tilt, of course, the solar resource, different sources. I used to go with Solar GIS, but of course there are many other suppliers. So there are also many times you have access to local meteorological stations that can provide some more accurate data. Then you have to compare, of course, different sources and try to find the best accuracy. And it is important also the albedo, and nowadays that the bifacial modules are, let's say, it seems to be the future. This is a very important, let's say, parameter for your simulations. Also, regarding the interconnection, you need to consider the line length, what's the voltage in the substation, what's the gray code requirements, and of course the interconnection losses. Well, also some other parameters to consider regarding the structure is the wind speed. For your losses, you need to also consider the temperatures also for the degradation of the modules. Soiling, dust, and humidity is a very important factor. So, well, there are many, let's say, boundary conditions that should take into account. For the EPC cost, you need also to consider the geotechnical and hydrological condition, like the soil type, the aggressiveness of the soil, the flooding risk, the let's say unexploited ammunition, these kind of things. Some projects have this risk, and you need also to consider this expansive clays and whatever you have there. Depending on the tender, the country, whatever, there are some special or particular conditions. For example, seasonal or hourly weight factors. We have seen, like in Abu Dhabi, that 13 months in summertime they pay more. So this can influence the final result of your analysis. So you need to consider also this weight. If they pay more in 13 hours or 13 months of the year, this may change the final design, and let's say you need to consider these factors. Okay, so the next step is to estimate. For your analysis, you need cost inputs. There are some fixed costs, like the interconnections on utility fees, and that typically this came with the project. These are costs that you cannot change. And then, there are some costs that are proportional to the nominal power of the project, like the step-up substation or the inverters, the power stations. Then there are some other costs that are proportional to the peak power, to the DC peak power. These are the modules, the structures, part of the BOS, the cabling or whatever. And typically also the land lease cost, and is a small factor, but it should be also considered. Well, for each country, some other costs can change. Not the skill or unskilled labor cost. The spare part typically is a standard cost, but well, you also need to consider. And this is a very important factor depending on the area. That is the module cleaning concept. Depending on the soiling accumulation and the water cost, the labor cost, and so on. You need to decide what module cleaning concept you want to use. You have different choices, like the robotic cleaning solutions. You have manual or semi-manual. So you need to analyze all these options and to let's say to see which one is the best. So just some examples of what we are doing here. when we have all these inputs that we have mentioned, we start an iterative process, scanning all the different scenarios. Let's say, first of all, you have to decide the type of structure you want to use, not if it is thick steel or if it is single axis trackers, or in some cases we have chosen this thick solution because we want to combat to install as much peak power as possible. Then we run this tiled scanning, the DCAC scanning, the ground cover ratio scanning. Let's say using different combinations to find which one is the best scenario. So I can tell you that for some projects we have run around 100 simulations with all these different parameters to find the optimal solution. So this can be a long process, and there are many factors there. So one thing that should be considered or should be taken into account is the relation between the DC-AC ratio and in the long term. So this in the short term, the high DC-AC ratio is let's say is triggering higher losses in the inverters and higher losses in terms of curtailment. But in the long term, because of the degradation of the modules and all the components, not the inverters also degrade and so on, you came to the conclusion that in 25 or 30 years, maybe it makes sense to increase the DC-AC ratio at the beginning, because at the end of all this period, the result in terms of LCOE will be better, no? So this is also very important. When we are running the simulations, we run the simulation not only for the first year, we run the simulation for the 25 years, and it's not linear. I mean, you have to consider that in the first, for example, 5 years, if you have a high DC-AC ratio, your curtailment will be lower, and in terms of energy degradation, it will not be the same than the module degradation. If you have a 0.5% in terms of module degradation, this will not result in 0.5% of energy degradation. In terms of energy, it could be 0.2 easily, because you have less curtailment and some components can run with higher efficiency. So I really recommend to run, let's say single simulation for each year to really consider what's the losses that you are having, no? Also, some interesting things are as you probably know, that if you have higher wattage, you can reduce your BOS, no, because you need less extractor, less surface, you have less losses in the cable, and so on. So with all these results, we used to run let's say a post processing to find also from the financial point of view, and the let's say having all into account which one is the best scenario. In this step, you need also to consider if there is any particular evaluation formula in the tender process. This happened to us in Abu Dhabi. In Abu Dhabi, the weight of produce more energy was let's say more important than let's say to have a higher specific production. So at the end of the day, we find that the best solution was to install all the modules flat all together. So we install, let's say, the modules in these thick-tack extractors, and let's say we found that this was the best solution for this particular tender. No, typically it's not the best solution, but for this evaluation formula, it was this was the best solution. Well, basically, this will result in a best scenario. So, let's say the output of this analysis is the DC-AC ratio, the capacity, the nominal, the peak power, and the ground cover ratio. So, with all these values, you need to let's say to decide basically the module technology, the kind of inverter that you want to use. No, there are some benefits using the string inverters in certain projects, basically projects that are far away in the middle of nowhere, because you can reduce the OPEX a lot. You don't need to have special, let's say, skilled technicians that provide the technical support for the inverter operation. And basically, you just need to have in your spare parts a certain number of string inverters that can really reduce your OPEX in some projects. No, well, then you need to consider also for the operation and maintenance concept, if you want to do it in-house or you want to outsource. As I mentioned before, the module cleaning is critical in some projects. So you need to analyze what's the best solution. Let's say considering the water cost, the labor cost, the climate conditions, of course, and so on. And also, well, there are some other factors, not like the accessibility and so on. So regarding the OPEX cost, there are some key points to reduce this cost. One is let's say to have a good management system. No, that is very important to be efficient. Then you can let's say think about low cost preventive maintenance, like the using drones for the air inspections. Or using robots for the cleaning. Yeah, there are many solutions around there that can reduce a lot your preventive maintenance. For the yeah, right now there is a big discussion regarding this string central inverters. I can mention here that in the last projects we are let's say very happy to use string inverters, because we see that there is a benefit, a clear benefit in the long term. No? And in some projects like in Abu Dhabi, we plan to use these robots to clean modules, because we really think that this can, well, first of all, we can reduce a lot the soiling losses. That is very important in this area, and we can also reduce the cost, because it is dry cleaning, so we don't need water. So there are many benefits by using the robotic cleaning. Well, finally, we have a design, no? Basically, the AC capacity, DC capacity, the ground cover ratio, the layout, single line diagrams, and the energy performance, the P50, 75, whatever, the O&M cost estimation. With this, we can, let's say, provide an LSUE and an offer, no? So, or start a tender process or whatever. But this is the process that we run when we start a tender process. So, well, I think that's all from my side. That's my presentation. So yeah, I think that there is a turn of questions later. So yeah, thank you very much for your attention.
Thank you very much, Eduardo, for giving us the developer's perspective. Okay, so if I can ask you to stop sharing your screen, and then we can give the screen to Vikas. Just whilst Vikas shares the screen, remember we have a Q&A box available at the bottom. You can send your questions through that, and we are recording this webinar, and we'll send you the presentations and also the recording. Do you want to put that in full screen, Vikas? And remember to unmute your microphone, and you're good to go.
Good afternoon, everybody. It's great to see people from all over the world on this webinar. From Sterling and Wilson side, I would be focusing more on the commercial aspects of the plant. I think Eduardo has done a great job in covering the technical part, and my focus would be more on the commercial side of the solar plant, and I would focus on areas which will help us become more competitive, on building solar plants, and which will help us extracting the maximum possible energy out of the solar plants. So, okay, so a broad breakup. We have got about 80% of the cost, which comes from supply, and we have got about 20% of the cost, which comes from services. So you have PV modules, tracker inverters, you have civil erection, all those things, which are the major drivers of building a solar power plant. So we all know these are the major things which go into building the plant. So I can say that 95% of the people know 95% of the things, but there are few 5% things which nobody knows. So you will have to go through the entire presentation to find out which 5% you don't know. So bear with me. Yeah. So when you get into any bidding, when you build a solar power plant, whenever you have uncertainties, we tend to fluff our cost, because we do not have the right answers for the uncertainties. So at Sterling and Wilson, and overall, you need to have a long-term strategy for the country. For example, if you are bidding in Saudi Arabia, you need to spend a lot of time in Saudi Arabia understanding various parameters. And why do we do that? The more we know about the country, the more the less uncertainties we will have, and obviously the overall bid will be more sharp. And at the same time, we have to remember that nowadays, as Belen said, we are counting pennies. We are not talking about dollars anymore. So when we are counting pennies, when we are up against people who are very serious about the solar business, we have to get into a lot of detail about every region, about every country, wherever we want to win. So let me give you an example. When we were working in countries like Argentina or Brazil, we found it so difficult to get a hang around the real taxation. It took us more than 3 months to really understand what is the best possible structure for the taxation. And after 3 months, we were able to save almost 3 to 4% of the additional cost which we were building into the system. So taxation plays a very, very important role in ensuring that we have the right capex. At the same time, let me give you an example on transmission and distribution. So whenever anybody goes to a new country, transmission distribution always is one area which takes a lot of time for people to understand. And since we don't understand transmission distribution in general well, we tend to overload or overestimate our cost on the transmission distribution side. So our recommendation is we really need to engage with the right local partners for the transmission distribution cost. Spend a lot of time understanding the cost, and rather than building a lot of contingencies around that, try and be more sharp on the numbers. So it all means that you have to spend more time. You need to have a long-term strategy for that country, and yeah. So similarly, logistics. This is one area which I personally feel is nobody gives enough importance to this part. As per my experience, between countries, the cost of logistics could vary from X to 3X. For example, if you're building a plant in Nigeria, the logistics cost could be as high as 10% of the project value, which nobody can imagine. And if you're building a plant in Abu Dhabi, which is more connected, the cost of logistics could be as less as 1% or 2% of the project value. So when you have to fix the logistics cost, go to the local supplier, local agents. Don't depend on all the big companies, because they are the right people who give you a very, very sharp understanding of the local logistics. At the same time, okay, so let me spend a little bit of time on how to extract the maximum possible value out of the plant. Eduardo spent some time on the technical part of it. Let me try and expand more on what he said. So in terms of the best output from the PV plant, as was Eduardo discussed, we have to do a lot of scenarios. For example, in a typical, if I talk about a 100 megawatt plant, in order to find the best possible scenario, we had to do more than 100 simulations on the plant. So you have to do AC/DC capacity, you have to do various type of module wattages. Do we use 300 watt peak? It will be the cheapest, but what about the BOS cost? What should be the right AC/DC capacity? Do we go for 1.1, 1.2 factors? So these factors, I would say, we have got about 6 drivers for the simulation, and when you do various permutation and combinations from these 6 drivers, you really get to the right scenario, which could give you the best LCOE. Because at the end of the day, it's not about how much money you are going to put in building a plant. It's about what is your per unit cost of electricity of the plant. At the same time, I would like to pick up a discussion on local content. So a lot of time when we say local content, everywhere in the world, people think local content means cost. More local content, more cost. This could be true for about, I would say, 70% of the items. But as per our experience, for example, in countries like Morocco, in countries like Saudi Arabia, there are few items, those 20-30% items which you can still buy from the local market if you spend enough time in the market, and you will be surprised. You will be able to save on the cost, and at the same time, you will be able to meet your local content. So, as I said, the theme of the entire presentation is we need to have a long-term, strategy on a country which will help us, minimize all of these things. Let me get into subcontractors. So whenever you build a plant, for example, whenever Sterling and Wilson will build a plant, the initial tendency is to just go to all the known subcontractors and give all the work to them. What we have seen is there are few areas which has to be done by the local companies because they are very good at it. They are very, very competitive. You may need to spend a lot of time with them, but at the same time, there are few activities which you have to outsource. So as a part of our strategy, 70% of the work which we subcontracted goes to the local companies. There is this 30% very highly specialized mechanized job which only goes to the companies which have got experience in. So with this blend of 70-30, approximately, we are able to always make ourselves competitive on the local cost. And obviously, local cost, although it's a 20% part of the entire bid, but this 20%, if it comes down by 10%, it will change your overall cost by 2%, which in a present scenario is a big number. Since we are talking about 1 cent or $2 bids here, every penny which we are able to save in building a solar plant, it matters. Second, I would like to talk a bit about the contingency part of it. So a lot of time when we get into the bids with developers, everybody wants to sort of keep everything a bit safe. Still, your EPC will build a small pool of contingency in their cost. IPPs at the same time, they have their own risks. They would want to build some part of contingencies in their risks. So my understanding is if EPCs and IPPs work together more closely, they are more open about this pool which could be shared. This can really help them knock off maybe 1% or 1.5%, because they in the end may discover that they were using the same set of contingencies which were a duplication. So that's one. Let me get more technical. So when you build a solar power plant nowadays, all utilities want you to ensure that the reactive power compensation of the grid is met. You go to any country in the world, utilities are very worried about the standards of the solar power plant, and they want you to ensure that it is as per the local standards. That said, when you have to meet reactive power compensation of a plant, it could be met through capacitors, or it could be met through inverters. So what we have seen is it is much cheaper to meet this requirement through a capacitor bank, which could be 1/5. Which could be 1/5 the cost of an inverter. So always try and use capacitor banks first, and then use more number of inverters to meet the reactive power requirement. Let me come to a very interesting topic. Our learning and observation for the last few years. So when we build plants all over the world, there is this corrosion level which plays a very important role in deciding what kind of structure we will use for the plants. And normally, if you have to do a theoretical study sitting on the desktop, you will always get a very surprising result. But if you have time, and if you again have a long-term strategy for the country, you should go for a corrosion test. They call it wire on the gold test. Go for the test. It is a 3-month test. It will give you the right corrosion level for that country. And between C2, C3, or C4, for example, if we go from C3 to C4, the price average is about half a dollar cent, which is a lot. So if you want to be really sure about what is the right corrosion level, and you don't want to again assume anything, go for this test. It will really help you bring your capex down. Secondly, there are a lot of places in the world, for example, Abu Dhabi being one, wherein we can use a east-west configuration for a large-scale plant. So normally people use east-west for a rooftop, but nowadays, I can tell you that the plant which we are building in Abu Dhabi, this plant is based on east-west configuration. This will be the largest plant in the world, 1.2 gigawatts on east-west. So east-west configuration at some places which are near to equator can give you a very, very good LCOE. It is much cheaper to build plants with east-west configuration, but they do not work everywhere. The higher you go in terms of latitude, they don't work, but near to the equator, they can really work well. So always try and check whether east-west will work in your scenario or no. Second, as I said, wind speed. Again, wind speed is one area wherein a lot of assumptions are made around this area. For the lack of data, it takes about a few months to get this data right. And if you have the right data, you can save almost 1 to 2% of your capex. Last but not the least, let me go into the operation and maintenance. So till now, we never thought, up till last year, we never thought robots could be the right solution. But surprisingly, in the last few years, we have discovered that the cost of robots has really come down. It could be very, very beneficial to use robots to clean the plant. That said, there are countries, for example, in India or in countries where the labor cost is less, it still doesn't make sense to use robots. But when you go to Middle East or Europe or US, it now makes a lot of sense to use robots. Sterling and Wilson is now testing more than 5 robots in Dubai, and we have a very good view on which are the right technologies to use. That's one. Second, I would like to pick up very commercial point, which is on the SLA. So a lot of time, everybody wants to be sure that their inverters are working, their trackers are working, they have more than 99% uptime, and in the process they end up signing very expensive SLAs, which is a service level agreement with inverter manufacturers or tracker manufacturers. As per our experience, inverters and trackers have become very, very standard nowadays. The complexity or the understanding has really improved in the last few years. So rather than getting into long-term SLAs, it could be much, much cheaper for EPCs or IPPs to train a few people and put them in the plants. And these people, I can tell you with a lot of confidence that more than 95 to 97% of the problems could be solved by only these people. So that way you can really become very, very competitive on your operation and maintenance cost. Yeah. So I think that's all from my end. If I would like to summarize, I would only like to say that for nowadays, it's very, very competitive out there. We are dealing with very, very serious, companies in PV market. So if one has to be competitive, one has to have a long-term strategy for that particular country. We need to keep uncertainties to the minimum, and at the same time, technically, we have to do the hard work, do your 100 scenarios, and get the best configuration of the plant. That's all from my side. Thanks a lot.
Thank you very much, Vikas. Okay, just really quickly to our 3 panelists. Roughly, how much experience in your company yourselves with PV in terms of gigawatts do you have, so that people in the room understand, because your company, how many gigawatts have you built?
Sterling and Wilson has already built more than 2,000 megawatt all over the world. Right now, we are building 1,700 megawatt again in more than 10 countries, and we are working in solar for the last 7 years, and yeah.
Yeah, okay. Eduardo, what about you guys? You guys have a lot of experience, but just so that people understand, you know, because maybe some people don't.
Sure. Yeah. I didn't catch your
Sorry, yeah, I was just saying, what is your experience in terms of megawatts in PV?
Well, we are right now. We have, let's say, 1.8 gigawatts. So
Okay.
yeah, in out of China. So in China we have a lot more. Yeah.
Okay. Excellent. And Alvaro, how much experience does that have, like in total, more or less, in PV projects?
Well, let's say that we have participated in more than 21 gigawatts in renewables in general, and out of which like 15 gigawatts would be in PV.
Okay, just so that you guys have an idea what we're talking about here. So, Alvaro, I know you're next, but before we go on, you know, we've been talking a lot about technical considerations, and people actually have a lot of technical questions. And just a little question for you before, Alvaro, you give your considerations is, how big is the technical considerations compared maybe to the financial considerations that you have to take in terms of restructuring the finance of the plant? Because we haven't really discussed this. This is not what we're here to do, but I think we should give an idea of, you know, what is the weighting? Because all of the questions we're having are mainly technical.
Yeah, that's a very good question. Yeah, and I believe that it is extremely important, the financial side. Let's say. So you can play with the technical side, but at the end of the day, it's more a financial problem than a technical. Yeah. You can squeeze the technical side, but at a certain point, you need to squeeze your financial model. Yeah.
Because you want to add anything there?
I just want to say that now that if you have to build a plant in country like Dubai or anywhere in Middle East, where the cost of funding is very less, in that scenario, the technical part of the plant has a major role to play. I don't have a right number. I would say, as per my information, about 70% to 80% consideration, because the cost of funding is really low. So your technical and the capex plays a very, very important role. But if you talk about countries like India or Bangladesh, where the cost of funding is very, very high, there the consideration comes down from maybe 70-30, maybe it becomes 60-40 or 50-50. So that's my broad understanding.
Yeah, fully agree.
Right.
Yeah.
Okay, so obviously it's about just so that people understand, you know, in case they're a bit out of. Okay, Alvaro, I'm going to give you the microphone to you. Just one thing, because can you actually stop sharing your screen if you don't mind now? And then we'll take it from there. Yeah, Alvaro.
Yeah, thank you, Belén. So, hello everybody. It's gonna be difficult to act as third speaker because most of the things that I was thinking about talking about have already been highlighted by Vikas and Eduardo. Those were very good presentations and already addressed most of the major topics that we could address for when talking about the optimization of the PV plants. But well, I will try. I will provide a brief speak. So what can we do if we want to make a PV project more competitive? So the first highlight I would like to share is that there is not a specific action to be put in place on a specific strategy, but in the end, optimization consists on putting together and combining a series of action, a series of small wins through the project so that we can achieve this competitiveness. Okay? So in this context, optimization shall not be performed only on the technical side, as we have already discussed, also on the finance side, also on the procurement. It is important to have a strong procurement to properly negotiate all procurement contracts and so on. So it's a matter of combining things, okay? Also, optimization is not only applying to any very specific project phase, but it shall be applied to all project phases, okay? From development, financing, design, construction, operation, and any other subphase. So having said that, I'm going to focus on technical issues as technical advisors and based on our previous experience. Although I will provide some comments and topics on every project phase, and will focus a bit more on the design part. Okay, so first of all, for the development, obviously, and it has already been highlighted by Eduardo and Vikas, it is important to have a good site. If you are tendering for a tender, the site is already given normally, but if you are doing your own development, you can select the site. So a good site selection is very important. It's not only selecting that site with a better resource, but also the orography has to be good, cell condition, proximity to the grid connection point. Also, the system or the proposed grid connection point shall be capable of accepting all the energy to be feeding, and also it shall be placed close to the site. The permitting shall be properly performed. Usually, this requires very good local knowledge and also local presence. This cannot be done remotely, or this should not be done remotely. Very important issue is the permitting of the interconnection line. We have seen many projects in which the permitting for the servitudes and so on for the interconnection line have been performed at the very end of the permitting phase, and this let's say in importance is similar to the importance of the permitting for the PV plant. Okay. Then for the financing, we can talk about this, but focusing on the technical side, a proper definition of the technical inputs of the financial model, it's critical to obtain a good financing or an optimized financing and estimating financial model. So proper definition of maintenance reserve account, taking into account real expenses you are going to have during your lifetime. Also proper definition of contingencies, realistic energy production and degradation figures for which we have to use accurate prediction tools. In some cases we can be forced, or the financial institution prefer to use more conservative values, and well, the developer and the advisor are there to not to convince, let's say, to demonstrate to them that we have to use realistic figures, and we already have very good accurate tools to predict the energy production, the solar resource in a very accurate way. Okay. Then the construction, I would like to highlight that the pre-construction is very important. It is best to spend extra time at this stage organizing the time here and making sure that everybody understands what is happening when during construction. This will save time and avoid mistakes later. Okay. Also, the project's execution itself is very important. A proper management of the construction, using good subcontractors with experience. Also for the supervisors during the construction, qualified key positions are extremely important. So the project director, project manager, outside supervisor have to be qualified, have to have experience, and they have to use supervision tools, particularly asset for the project, and that are demonstrated to be used for controlling the progress and the quality of the works. During operation, it is important to have a good monitoring system to properly understand what is happening in the plant. Also, it is important to properly define the O&M task. This will depend on the project's characteristics, also on the site, and also on the, let's say, the boundary condition. We have to adapt to the boundary condition. A good example would be in Spain, when the remuneration is limited above a certain numbers of kilowatt hours per installation. So in this case, it may be the case that it is not, it doesn't have sense to make so many cleanings or to make too many operation actions. Also, it is important to operate the plant in such a way to anticipate that the lifetime could go beyond 30 and even 35 years. We really think that the PV plants are ready to go beyond that period for lifetime, over 30 and even over 35, but we have to take some special care during operation to anticipate this life extension. Okay. And then for the design, well, the first input to be considered here is that the technical optimization has to be performed together with the financial model. So we are not looking to get the optimal technical solution, but we are trying to get a technical solution which is good, which is reliable, but which also optimizes the financial model. I think Eduardo already provide a very good detail on the process of the optimization for selecting the configuration and so on. So firstly, we have to select the recommended project configuration, which consists on defining a number of scenarios and then simulating all of them, and together with the financial model, selecting which one is the recommended one. Okay. So this not only consists on simulation of the energy production, but also we have to prepare a balance of material for each of the scenarios and estimates of the BOM, so that we can run the simulation of the financial model and we can obtain a preliminary financial model results, and then we can select the recommended project configuration. When the recommended project configuration is selected, which will be different depending on the project site and the project characteristic and the location and so on. And then we have to start the optimization project for that, the optimization phase for that specific project configuration, which consists on allocating roads, allocating stream boxes, and so on. What else? So, apart from this optimization of the design, there are some other key aspects that I would like to highlight. Very briefly, for instance, in case of power limitations, we have to clearly know where is the power limitation applying, because in some cases we don't have to design the plan to respect this power limitation. We can design the plan over this power limitation and assume that at the beginning of the lifetime, part of the energy may not be injected into the grid because the injection is limited. But even in that case, it may be the case that the financial model is better, assuming the part of the energy will not be fitting. Also, regarding some technology improvements, well, every day we are seeing new trends.
One minute, I give you a minute and then I have to cut you off. Sorry, I want to ask some questions.
No problem, it's just 3 topics. So the first one is the technical improvements, dual glass, 1,500 volts and so on. They are becoming real, and then we are already hearing about new trends for the next year or for the new months, bifacial connection in high voltage DC and so on. And also final mention to electrical storage, okay, which is becoming a key issue, and that will regarding the optimization of the design this will be key because it's much more difficult to simulate the optimal scenario including storage than not including storage. So in conclusion, there are easy big wins in optimization of PV, but optimization comes from combining a series of small wins through the project, and there are still places for improvements.
Thank you very much, guys. Thank you very much, Alvaro. That's always a good summary as well. Just let me ask you guys, what is the shortest PPA you've come across? Someone asked here, and I know, it's very variable, it depends on many items, but what is the shortest that you could have a PPA these days for PV, like realistically?
So I can split my answer into 2 parts. For the utility, I have seen 10 years as a shortest PPA. There are a lot of utilities in US, even Australia, who are happy doing, even Ghana for that matter, who are happy doing a 10-year PPA. But when it comes to the private PPAs, we have been working on several mining projects and they had only PPA of 5 years. So although it's very difficult to make the numbers work, but people still went ahead and they had a 5-year PPA for the solar power plant. So 5 and 10 is the shortest I've seen in the last few years.
Yeah. As an IPP, we never goes for PPAs below 15 years. So 10 years or 5 years is not an option for us.
So that's the shortest, and I don't suppose that's going to come down any further, right? Like this is.
Yeah, you also need to consider, of course, the pool price, the market price, and so on, because typically late after the PPA, you can sell the energy to the free market, but you never know, and this is a high risk. I mean, you have to consider that this is a high risk. Yeah.
Okay, you guys. Obviously, people here, this was a technical webinar, and people here were really asking very specific questions and technical considerations. I have just a vague understanding, but some of the things that have been coming up and up again through the Q&A and also through the chat is the 1,500 volt systems, the glass-to-glass module, the bifacial modules, the robot cleaning. I know, I guess in one way you could say, okay, take them all out, do them all, follow them all, but I assume, I mean, doing them all is a very high risk in technological terms. So I just wanted to ask you, are you a fan of any specific innovation that you're like, yeah, this is something that we want to do? And do you think, oh, I'm not so sure about this one? I mean, do you have preferences in these terms? Are you just going for everything? What is your sort of strategy in terms of innovation?
Well, it seems that the future right now is the bifacial modules. Everybody is speaking about that. So yeah, well, we are analyzing this new technology. We don't have a clear idea right now of what will be the gain with that technology. But we are in the process of analyzing this improvement. Yeah.
I would just like to add a point on the dynamic tracking. So everybody, I'm assuming, is aware that in the last 3 years, a shift from the fixed point structure to a tracking has taken place. Now everybody wants to go for single axis tracker. Now the second innovation is all the tracking is as of now static. So you put a program in the tracker which will track it the way it wants to track. It's not dynamic. The new innovation is, you have multiple sensors around the plant. They know what is the weather condition. They know what is the cloud condition, and they are able to dynamically track the sun. This can give you 2 to 5% more, output. Although it is not proven as of now, the trials are going on, but it could give you 2 to 5% more than normal tracking point, which is a lot. So I would say big data analysis, because it involves a lot of analytics, and dynamic tracking. These are the two things which really excites me. I think people are going to adopt these two things very quickly in the next few quarters.
Yeah. One more comment. Something that I want to say is we are also considering, let's say, certain energy storage to reduce the curtailment. These kind of things can also help to improve the LCOE. So yeah, depending on the DC-AC ratio, if you have somehow high curtailment, you can use this kind of temporary storage. And the point is that right now the cost of this storage is extremely high, so we want to see lower prices to start implementing these solutions. Hello? Belén, we cannot hear you.
Guys, let's hold on for a moment till the time Belén comes back.
Álvaro, can you hear us?
Yes, I can hear you, but
okay. I think that Belén is having some problems.
Yeah, she's frozen.
Yes, I just arrived. I'm so sorry. Okay. Hi. Can you hear me now? Yeah. Okay, sorry about that. Just the last question, and I'm sorry I had this problem, this little. Just the last question. We were talking, because earlier about the next quantum leap in terms of getting those projects cheaper. So I want to know, what is the next quantum leap in your opinion? You know, we talked about data, we talked about artificial intelligence, we talked about automation.
Yeah. So
Are any of these things on the line?
So I think everybody knows that the price of the PV modules and everything else is coming down. I would like to focus more on automation. So what we have seen in the last few years, the way we used to build plant, 5 years back, is not the same way we are building the plants now. So a lot of the automation which is happening in the construction industry, solar will be adopting a lot of that automation for building solar power plants, and I think that has a good amount of role to play in bringing the cost down, especially if you talk about US, Australia, even Europe, where the cost of labor is very high. There it will create a lot of impact to bring the cost down very, very quickly. And I see this happening in the next 3 to 5 years, wherein we can build large solar power plants with very, very few people.
And Eduardo, do you have anything to add? And we'll say goodbye for next time.
No, nothing to add. So thank you very much for your time.
Okay, thank you very much, guys. Thank you very much to all of the audience for being here today. Thank you very much for our presenters, Vicar and Eduardo and Alvaro. And yeah, thank you. See you in the next webinar. Bye.
Bye.
Bye. Bye. Bye.